friends, welcome to Learning Earning. This is the first video on the first module, the Electrical Essentials. In this, you're going to learn the flow of energy and the primary components like resistors, capacitors and inductors. Well, jumping into the topic without any deviation, the flow of energy. Friends, the energy flows from source to the load. The energy emanates from the source and terminates at the load. Well, in this process, it gets transformed like from electrical domain to heat energy, or electrical domain to mechanical energy, or magnetic, or even translational mechanical energy, or it may get converted into these forms, and that's how it gets transformed while it flows from source to load. And even some energy gets simply lost, and that's how and where a resistor comes into the picture. Resistor dissipates the energy in the form of heat. Well, some amount of energy is even stored in the form of kinetic energy and potential energy, where in kinetic energy an inductor comes into the picture, and for potential energy a capacitor comes into the picture. So today we are going to learn about the resistor, the inductor and capacitor. So resistors. What are resistors? Well, resistors are the components, the physical components which are non-dynamic. They are not dynamic, they are algebraic. They don't have memory, they are passive components, they don't have memory. Their present value doesn't depend upon the previous value. Resistors simply dissipates the amount of energy which gets into the resistors into heat. The characteristics of resistor, we can call it as the VA characteristics, the voltage and current characteristics. On the x-axis, if at all you draw the independent component, the V, and on the y-axis, if at all you plot current, then the character of a resistor is simply a straight line which passes through the origin. Now, the slope is given by 1 by R. When you compare V as X and I as Y and M as R, we know that the equation of a straight line passing through the origin is Y is equal to mx, where C is eliminated because it is 0. Since the y-intercept is 0 here, since it is passing through the origin, Y is equal to mx, and therefore I equal to m, 1 by R into x, that is V. So here comes the governing formula called the Ohm's law. V is equal to R into I. This, my friends, it's called the Ohm's law. There might not be a day electrical engineer doesn't come across this formula. Everyone gets confronted with this formula ever since they start electrical engineering. Few characters of a resistor, if at all we discuss in detail, we can know that whenever this line, this straight line, tends towards or is tilted towards the I to the y-axis, then 1 by R is going to be infinity. That implies R equal to 0. My friends, this in this direction it is 90 degrees, and tan 90 is infinity. Therefore 1 by R equal to infinity and R tends to 0. That means it is short-circuited. Whenever, see, this is that position. Whenever this straight line at some slope 1 by R tends towards the x-axis, that's towards the voltage, then tan theta becomes 0, since Theta is 0 here. 1 by R tends to 0, that implies R tends to infinity. That's the position where it gets open circuited. So the value of R is limited between 0 to infinity. That is 0 in short circuited conditions and infinity in open circuit conditions. So thus we understood that whenever we take a point on the x-axis, that is the voltage axis, and a point on y-axis or the current axis, draw a perpendicular to the slope, to this point, and join to the y-axis. There comes the governing law, V is equal to Ri, the Ohm's law. Now, what is the power dissipation and how much is the value of the power dissipated through a resistor? Well, we know power is given by voltage across resistor terminals into current passing through the resistor. So P, the power dissipated through resistor, is the product of the voltage across the resistor and the current passing through the resistor. Since we know that V is equal to R into I, the power dissipated can be written in terms of current or in terms of voltage. That is, if at all we substitute the value of V in this equation, it becomes IR into R into R, that is I square R. Well, if at all you substitute the value of I in this equation, it can be written as VR into VR by R, that is V square by R. So that's the value of the power dissipated through a resistor. In terms of I, it is I square R, and in terms of the voltage across the terminals, it is V square R by R. This implies VR is the voltage across resistor. Types of resistors which we are going to encounter in the following lectures or whenever you open the book. Types of resistors. Well, there are namely three types of resistors. There are carbon resistor composition, metal film, wire wound resistor. Well, the value of resistance of a resistor is given by the symbol code. The coding of a resistor is not shown. Okay, the simple way how to remember the color codes of a resistor is this: B, Roy, Great Britain, and very good wine. So from here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here B is black and this is brown, red, orange, yellow, green, blue, violet, gray, and finally, what's this? White. So these are the color codes for a resistor. The simple way to note them is through B, R, O, Y, Roy, Great Britain, very good wine. So these are the color codes. And so how to find the value of a resistor when a resistor is given? Well, the resistor looks like this. I'm not good at drawing, but you have to adjust. So this is the gold band. It might be a gold band or of any different color, which actually shows the variation of resistance with temperature. The value of resistance even changes with the change in the temperature. So that level is called as tolerance, is indicated by this gold band. And the three bands, a red color, a blue color, and a black, R, B, and black. So consider this as the resistor which we have right now. So what is the value of the resistance in this resistor? Well, you have to see the first band red, that is 2, and the second digit here is the value of blue, that is 6, into the multiplying factor is the third band, that is 10 power, black value is 0. So that is equal to 26 into 1, that is equal to 26 ohms. And the symbol or the representation of resistor is to the Greek letter omega, that is this. So 26 ohms is the value of this kind of a resistor. So the resistance of each and every resistor can be calculated through the color codings and the values respectively. Thus, a resistor is defined and the characteristics of resistor are obtained, and we even saw how the value of resistance changes due to the variation of temperature, which is called as a tolerance level, and we have seen the color codings to know the resistance value of a resistor. Well, and even we have seen the governing principle, that is V is equal to R into I, where R is the resistance and I is the current through the resistor, and VR is a voltage across the resistor terminals. And we have even derived an expression to find the power dissipated in a resistor, that is I square R if at all we take in terms of current, and the power dissipated through a resistor by taking voltage into consideration, it is V square by R. So that's how a resistor is defined, and you can go through a series of books to know more about the resistors.